Okay, here is a numerical example on the usage of VT graph. Look at the problem. The velocity time graph of an athlete running on a track is as shown. Calculate the total distance traveled in 16 seconds, and we also need to find out the acceleration at t is equal to 11 seconds. Let's look at it. Here is the graph. What are the calculations required? Distance covered in 16 seconds, and we also need to find out the acceleration in what intervals of time? Acceleration in t is equal to 11 seconds. So, we need to calculate this. I will come back to this question, just a second. So, here is the numerical problem which asks for distance travelled in 16 seconds. So, how to calculate the distance travelled? You know this. Distance travelled is equal to area. That's right. Distance travelled is equal to area. Now, if you look at it, we need to calculate the area of this part. So, part 1, part 2 and part 3. So, total area distance is equal to area of 1. Area of 1, what is this side? This is 0 to 8. 8 into, we should be little careful. So, we want this distance. What is this? This is 2, 4, 6, 8, 10, 12. So, 10 minus 2, that is 8. That is first part. Area of the second part. Area of the second part is the area of a triangle plus a rectangle. Area of the triangle is half into. The base of this triangle is 2. The height of the triangle is how much? 8 to 4, so 4, plus area of the rectangular part 2 into 0 to 4, 4, plus area of the last part. This is of side 4, so 4 into height is again 4. So, let us simplify. 64 plus these two cancel. This is 8 plus 4, 12 plus 16. Is that correct? Yes. So, if we add them all, what is it we get? 92 meters. 92 meters is the distance travelled by the particle. Second part of the question. Acceleration at what instant? The acceleration at t is equal to 11 seconds. Okay. So, let us consider this. Remember, this is 10 and the acceleration at t is equal to 11 seconds is here, which means that we are actually interested only in this part. Is the acceleration constant over there? Yes. How do we know? It is a straight line. So, acceleration is constant. And how do I calculate? Acceleration is given by slope. And is that a positive acceleration or negative acceleration? Negative. How do I get it? You know, it is final velocity minus initial velocity divided by time interval. What is the final velocity? Final velocity is 4, initial velocity is 8, and what's the time interval over which this entire curve is treated? That is 12 minus 10. This is minus 4 divided by 2. That's nothing but minus 2 meter per second square. Observe it. This is the curve, and this corresponds to V2. This corresponds to V1, this corresponds to T1, this corresponds to T2. That's right. Sorry, this is V2, this is V1. So, you need to consider the acceleration anywhere implies that this entire curve needs to be treated.